When people talk about crane electrical systems, they often focus on the major components: motors, drives, brakes, contactors, or PLCs. But in real engineering work, the quality of circuit design often determines whether a system is easy to maintain, easy to troubleshoot, and reliable over the long term. Good wiring is not just about appearance. A clean panel may look professional, but the real value is in how clearly the circuit is designed and how logically every function is organized. For a small or medium overhead crane, a more scientific electrical design usually starts with clear functional separation. Power circuits, control circuits, safety circuits, and feedback circuits should be clearly divided. If everything is mixed together without structure, troubleshooting becomes slow, modifications become risky, and even simple maintenance can lead to mistakes. The second point is proper numbering and identification. Every terminal, wire, relay contact, and device should be clearly labeled. In practice, many repeated crane faults are not difficult faults, they just take too long to locate because the wiring has poor identification or no consistent coding system. When the numbering is clear, an engineer can follow the logic much faster and isolate the fault with less downtime. The third point is logical terminal layout and routing. Terminals should be arranged by function, and wiring routes should be planned to reduce crossing, confusion, and unnecessary length. This matters not only for installation quality, but also for future service work. When a panel is designed logically, engineers can inspect it, test it, and modify it much more efficiently. Another important point is maintainability. A good crane control circuit should not only run correctly, it should also be easy to inspect, test, and repair. That means leaving enough space in the panel, using practical terminal grouping, reserving spare points where needed, and making key signals easy to measure. In engineering, a system that works today, but is difficult to service tomorrow is not a good design. Safety logic must also be clear. Limit switches, emergency stop circuits, brake control, and overload-related protection should all be designed in a way that is easy to understand and verify. If the safety chain is complicated but not transparent, maintenance personnel may struggle to diagnose the issue or, even worse, bypass something they should not. And finally, good design should consider future retrofit needs. Many cranes stay in service for years. If the original circuit design leaves room for upgrades, such as inverter control, remote diagnostics, or added safety devices, later modifications become much easier and more cost-effective. So, from an engineer's perspective, scientific circuit design is not just about making the crane run. It is about making the system safer, clearer, easier to maintain, and easier to upgrade over its full service life. If you work with crane electrical systems and want more practical content on control design, troubleshooting, maintenance, and retrofits, follow this channel for more real-world engineering insights.